space controller products for the safe and effective delivery of natural insecticides called pyrethrins into work and recreational areas. Not surprisingly, this created a demand for secure supplies of pyrethrin raw material of appropriate quality. A breeding program had already established that there were considerable benefits to be gained from the large-scale cultivation of improved varieties of the pyrethrum plant. This would give returns through plant uniformity, shape of plant, time of flowering, height of flowers above plant, quantity and quality of pyrethrins in the flowers, and so on. What was required, however, was the technology for generating large numbers of clonal plants for cultivation across thousands of hectares. It was here that the Australian company gained first-hand experience of the constraints on clonal plant propagation in agriculture. Through this experience, it instigated a program for the development of an automated micro-propagation capability. From the outset, CIG adopted a systems approach to the automation of micro-propagation. The tens of millions of plants to be produced would demand an integrated approach to materials handling throughout all unit operations in the production cycle, from accession of superior plantlets, kickstart, multiplication, grow-out, hardening, dispatch to growers, through to quality control and assurance. Careful consideration of the materials handling problem showed that the key constraint of conventional micropropagation is in the multiplication stage, the time and labour required for cutting up plant shoots to generate more plantlets. Labour costs can contribute between 65 and 80% of the total production budget. So it was this area that CIG tackled first. The specialised nature of the operation meant that appropriate off-the-shelf equipment was not available. Some preliminary experimentation with standard and special-purpose robotics equipment confirmed that the answer to the problem lay not in mimicking the human actions in conventional micropropagation, but in devising an unique and innovative system which achieved the same objective. In developing the automated cutting unit, 8 criteria were established as guidelines for specifications. The first was the overall cost of the unit. Second was high speed of operation to the order of tens of millions of cutting operations per annum. Third, the unit must have a high degree of accuracy both in cutting and planting operations. Fourth, there must be repeatability of this accuracy and speed. Fifth, a high sensitivity of operation so as to handle delicate biological tissue without bruising or damage. Sixth, there must be a capability to operate either aseptically for in vitro cultures or under standard clean conditions for cuttings which can be sown directly in a non-sterile medium. Seventh, a high degree of reliability enabling continuous operation for extended production runs. And finally, there must be flexibility in design, both in software and hardware, so that a range of plant species can be handled simply by selection of different software menus and a rapid changeover of gripping or cutting tools. As you can see, a multi-station vision-guided robotics cell has been developed which meets these criteria. In the few seconds it has taken to describe the benefits of the system, it has converted a row of 10 plants into 3 rows of 10 cuttings. One tray will go back into the multiplication area, where after 2 weeks or so, the plants will be ready for harvesting again. The other 2 trays go on to the grow-out stage, where they develop into full plantlets with roots and shoots. To complement the system, CIG's research team developed a special carousel unit to charge the automated cutting unit with the necessary numbers of selected superior clonal plants grown under strict aseptic conditions. An automatic tray forming and filling unit was devised capable of delivering seed pots far in excess of the number actually required by the cutting unit. The volume and aspect ratio of each pot were optimized to favor rapid growth of cuttings and avoid expensive wastage of the various specialized media dispensed by the system. At all stages of the operation, the plants are completely removed from their natural growing environment. So CIG has developed a system of hardening off, whereby the plantlets are subjected to a period of carefully selected and controlled conditions to ensure good survival rates after the plantlets are dispatched to customers. The precise conditions for these automated procedures have now been determined for a range of plants, including potato, several species of eucalypt, pyrethrum, and the tea tree oil plant Melaleuca alternifolia. An active marketing program has secured production contracts outside CIG to supply clonal plants to a range of growers around Australia. As validation of the quality of operational procedures in the automated micropropagation system, CIG can point to 1.5 million clonal pyrethrum plants produced as foundation stock for 50 million plants now under cultivation in Tasmania, Australia, and 25,000 eucalyptus being grown in most Australian states by both private and public companies and government departments. In summary, a multidisciplinary CIG team comprising mechanical, electrical and software engineers, plant physiologists and microbiologists has adopted a systems approach to the automation of micropropagation. Major developmental advances have been made in all critical operational activities. The group has developed the key elements in an integrated system for automated micropropagation of plants. The system now offers to the plant industry the benefits of high-volume production, reduced plantlet production costs by comparison with conventional tissue culture, reduced timescales for the commercialization of new genetic material, accelerated recovery of investment in breeding programs, quality and uniformity of planting material, operational productivity and reliability. These activities within CIG, the Australian subsidiary of BOC, reflect the spirit of innovation for competitive advantage, so prominent in its worldwide parent company, BOC.